Hi, Mr. True. Well, I've explained how the derivative of sine is equal to cosine, or at least stated it, and I explained with a graphical demonstration why the derivative with respect to x of cosine of x is equal to the negative sine of x. Now, we've got four other trig functions, of course, and we have to know the derivatives of those as well. So the derivative with respect to x of the secant of x is equal to the secant of x times the tangent of x. The derivative with respect to x of cosecant of x is equal to negative cosecant of x times cotangent of x. And so on, because I'm sure you can read this. So what we're going to do in this video is prove two of these four statements, and I'm sure in your homework you'll be required to prove, well, hopefully I'm not just giving you the answers to one of your homework problems, but you'll have to, should know how to prove the other two, whatever other two that I don't do. So we're going to take a look at the derivative with respect to x of the cosecant of x. Now, we're going to look at this the same way that we did our proofs in trigonometry, which is sine and cosine are the building blocks of the other four trig functions, like tangent is sine over cosine, and cosine, or cotangent, is cosine over sine. Well, cosecant is 1 over sine. So we have the derivative with respect to x of the cosecant of x. Well, I just told you what the answer was right here. But where does this come from? Like, why is there all of a sudden two trig functions? Well, to figure that out, we're going to write this in terms of sine and cosine, and that is going to be now the derivative with respect to x of 1 over the sine of x. Now, 1 over sine of x. Now we know how to we know that the derivative of sine is cosine, and I showed you the second statement graphically and related the two together to help, just so you accept it as true. And if I want to find the derivative of this, well, I have 1 divided by the sine of x, so that means that we need the quotient rule, since, at this point that's all we've covered. So the quotient rule says that we need to take the denominator, so that's going to be the sine, so this is going to be equal to the sine of x times the derivative with respect to x of 1 minus, okay, so it's denominator times the derivative of the numerator, and then it's the derivative of the, of the denominator times the numerator, all over the denominator squared. So it's going to be all over sine squared x. So the derivative of a constant is equal to 0. So this first term in the numerator is just going to be 0. Minus, so we have minus the derivative of sine is equal to cosine. So the derivative with respect to x of sine of x is equal to cosine of x times 1. All right, so over sine squared x. Well, that does not look like this. What are we doing again? Cosecant. Does not look like this. Negative cosecant of x, cotangent of x. And that's an issue when you do derivatives, especially with trig functions. You might have a correct answer. This is the derivative of the cosecant function. But darn it, when I go in the back of the book and I look at the answer, it doesn't match up. Or when I look at the formula or the rule that I just gave you, it doesn't match. So we're going to manipulate this a little bit. This has a squared trig function on the bottom, and these all have exponents of 1. Well, it'll be there. Anyway, so we're going to take this denominator and pull it apart and rewrite this as negative cosine x over the sine of x. And I'm going to show this as a complete different multiplication because here I have a term with two factors. So I have negative cosine x over sine x times, well, negative cosine x times what is going to equal negative cosine x? I got to multiply by 1 because I don't want the value to change. And we had a sine squared in the denominator, so that needs to be sine times sine. So now I can see a little bit better about where this is coming from, except mine's going to be in a different order, but multiplication is commutative. cosine over sine is cotangent. So this is negative cotangent. And 1 over sine x is cosecant x. And that is the end of my proof of this individual rule right here. Bye! We're going to do one more example, and that will be the end of this video. For our second and last example, we have the derivative with respect to x of the cotangent of x. Why is that equal to negative cosecant squared? Well, the building blocks for cotangent are cosine over sine. So this is equal to the derivative with respect to x of cosine of x over sine of x. And that means we're going to need the quotient rule again. So that is going to be equal to the denominator, so sine x times the derivative of the numerator, which is going to be, well, let's just write that out. Derivative with respect to x of cosine x minus, okay, so it was denominator, derivative of the numerator. Now it's the derivative of the denominator. Times the numerator. All over the denominator squared. Okay, so we have sine x, the derivative of cosine is negative sine, minus the derivative of sine, which is cosine, over sine squared. Now, sine times sine, of course, is sine squared, but there's a negative there. So negative sine squared x minus cosine times cosine is cosine squared. So we have cosine squared x over sine squared x. So it's just like doing a trig proof. We have to keep, we're algebraically manipulating things along, but we're having to keep in mind our goal. I'm trying to make this equal to negative cosecant squared x to finish my proof. Never thought you'd be doing those again, maybe after you did them in trig. They do come back in calculus. So how am I going to get this to look like this? Well, cosecant is 1 over sine. Well, so far I've got sine and cosine. So I need to get this cosine squared out and replace it with sine if I have any hopes of getting this negative cosecant squared to show up. Well, negative sine squared x minus something over sine squared x. Pythagorean theorem, you had 3 of those to memorize in trigonometry, and they have to come back and you'll have to use them again in calculus. The first one was sine squared plus cosine squared equaled 1. So that means that if sine squared plus cosine squared equals 1, then cosine squared, if I take that sine squared and move it over, cosine squared is equal to 1 minus sine squared x. So now, if I take this negative sign and I distribute it through the parentheses, is that going to get me any closer? Had a little brain fade there. All right, so of course it is. So we're going to get, just run out of room here, we have negative 1. Now we have minus sine squared x, and negative times negative is positive. So we have a negative sine squared x, and what will be with this distribution a positive sine squared x. That means that these are going to cancel out. So I was trying to do a little bit in my head there because I was running out of room and just whatever. Spaced out. So we have negative 1 over sine squared x, and 1 over sine squared is equal to cosecant squared. So negative cosecant squared, and the end of my second proof is done. Now you go try and finish up the proofs for the last 2. Bye! I'm Mr. True. Go do your homework.